Okay, welcome back to another episode of Rightronics. As I said last time, I'm going to start and build that 555 UPS automation, and let's get started. I found a circuit online that I will just edit in so you can see what I'm building. But in the meantime, I need to have it on the screen so that I know what I'm doing here. And let's go. This should be the first pulse on power on trigger with the first 555. I don't know, I'll just have to see if it works. Looks promising though. Now I just want to solder this socket in, and I thought it fell. Just a couple of pins in diagonal corners, then the socket is held together for real, and you can just do whatever you want with the board. It won't fall off. Just touch each pin, careful not to solder them together. Sometimes you have to, but this soldering iron wire is so annoying. Might have to buy a soldering station. It's quite stupid too. It's like a 15-watt soldering iron, and it has a cable the thickness of my washing machine power cable. So I don't really understand what's the point of this. You can literally run this through hair thin wires and nothing will overheat at 15 watts. But whatever floats their boat. So this is where the 555 will sit. There's no point in planting the IC so far. We're just gonna place the components around it. Okay, so pin 1 goes to ground. Ground is ground, so pin 1. I really hate these schematics when where the ground, instead of just making a line cross all the way through the components, is just separate arrows. It's kind of confusing. So I'll have a 1 mega ohm resistor between 1 and 2 pins. I think I'll actually have to measure this one again because I have no idea which one of them. It should be the one with green. Yep. And this one needs to go between pins 1 and 2. Got a bunch of capacitors too to try different values until I get the right timing. I found this kind of board to be a lot more practical for like small projects like these that aren't really that demanding. Just tracing the circuit around with nothing but solder, just pouring the solder, from component to component until I have the circuit. Of course, for more demanding circuits like audio stuff, amplifiers, and more complicated, sensitive things, you'd have to design a proper PCB. But for this kind of quick stuff, it's really, really, really fast. And I can't imagine what it would be now to actually build the printed circuit too before doing all this. Now you just go through with the components through the board and solder them, and that's it. In a couple of minutes you have the circuit. It's really, really nice for this kind of application. So now I just go ahead and pour some solder until I get a connection, and that's it. That's how you do the circuit. And most of the times you have to wait until these blobs cool down, because if you try to keep pouring, it just forms a kind of a sphere-shaped blob. Kind of wants to, being a liquid, it tends to become a sphere shape. If you wait for it to cool down, you can actually connect it way faster. There you go. If I wouldn't have let this cool down, I couldn't solder it, because it kind of stays in that shape and then the new solder attaches to it without any deformation. If you don't wait for it to cool down, you're just making a huge sphere, a huge ball, and you're not going anywhere with that. Okay, that's a resistor. Between pins 2 and 4, I'm gonna go ahead and put the original schematic is a 10 microfarad. This is gonna be, I'm gonna try a 4.7. I don't think there's any chance for that to show up on the camera. Let's see if I can zoom in a bit. Microfarad. I'm assuming the minus, they're not shown as electrolytics in the circuit diagram, but I don't think they meant that. So you're obviously using electrolytics with this kind of stuff. Between 2 and 4, 4 being VCC, well, connected to VCC because it's reset. I'm gonna go ahead and say that the minus is on pin 2. Then I'm gonna have pin 3 with a signal. I think I can go from the bottom. So again, pin 2 and 4. This one's gonna be pin 2. Make sure to get out on camera. Sometimes the pins of future components to be put in help as well with the circuit. And this one is 4. Okay, that's nice so far. Between these two, I'm gonna have a diode. Now let's see the diode. Cathode towards the capacitor. It's already shaped a bit. That's nice. And then at the anode, a 470K resistor, which is the only one of the two resistors. Well, actually, no, I have two resistors left, and they're both 470K. And between the anode and the other side of the capacitor, which will translate to, I'll actually make it look in the same way as the diode. So that would look fancy on either side like that. Now I have to keep it with my fingers. Until you feel that sweet burn. Okay, and so these two go together. So I set anode to 470K. Good. I'm gonna solder the other pin of the resistor or it's gonna fall off. And that's what I said with the blob, you know, I made this blob. I'll just wait a minute. Well, not actually a minute, a few seconds. And then, you see, it connects right away. No worries whatsoever. So I get anode to diode to resistor, and resistor goes to the other side of the capacitor, all the way to pin 4. Again, made the blob. Now I'm waiting. Sometimes it helps if you tilt the board so that the solder can flow as it's liquid. But bear in mind, if this is a problem to you, that doing this method for a PCB will definitely eat up a lot of solder. So, but that's no issue for me. I mean, given the fact that you can build it so fast, I'd rather much buy 2 times the amount of solder. So there you go. I have that diode. Then 100 micro capacitor that I have right here. going from the same anode and the same diode, and I have to clean up this capacitor a little bit. With the plus in the, where does the minus go? Ground. Ground goes to pin 1. Pin 1. And I'm gonna have this, right? Like so. This is gonna be another tricky one-hand job. So the plus of the capacitor going to diode's anode. Are these connected? Now they are. And the other side with pin 1 and you have the resistor. So these two right here. See what I mean? I did the blobs. They're now cold and hot in liquid. Just wait a few seconds. They harden up. And then boom, go in another blob. See how cool it connects? Just like this. I think I'm done with this side. Of course, pin 4 connects to pin 8. And that's gonna be a bit of a problem. Should I go with an external wire? 4 and 8, 4 and 8. I think I'm gonna have to go with a wire for this. Okay, let's glue together pin 4. And pin 8. Okay. Next we have the same 470K between 7 and 8. I'm gonna go ahead and shape it like this. Again, wait a bit. Then blob. Six to seven. They are both the ones in the middle. I'm gonna have to be soldered together. So another blob there. Another capacitor, a tiny little one this time, 10 nanofarads, going from pin 5 to pin 1. So pin 1 is here. 1 is going to be pin 1 is going to be the ground. So I might just as well grab the ground, but then this will be the plus. I'm just taking the ground all the way up. Like so. And the way you do this is you solder all these rings and then go with a blob every 2 holes. And just as I said before, just let them cool off. Wipe the soldering iron from time to time. You can blow on it, that makes it cool down faster. And then come with some more blobs between the cooled down blobs. Sometimes it doesn't work as expected. Sometimes it does. Blow on it. Another blob. Some more solder. Where is pin 5 now? It should be the edge. I have to straighten this capacitor too. I kind of want to see this working too. Maybe like this with the resistor. So going from pin 5, that would be the only one not connected yet, besides the output, which is pin 3. Again, rings, 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 blobs, blobs, blobs. Obviously, someone will tell me that I'm doing a great mistake by doing this, but it's just a 555. I understand all that with all the interference and currents, and it's really, really not the case here. There's nothing with high current, high power, nothing sensible like that. You just need to be connected one way or the other. So as long as the pins are connected, there's not much difference in how you do it. Okay, the other side, going to pin 1, which is the ground. Almost looks like a 7-segment LED display, doesn't it? With this figure 8 on it. Okay, that was the capacitor. Let's see if I have the positive side. Okay, so it's the capacitor with the resistance. It's the positive. With pin 4, with pin 8, it's the red wire. With, okay, resistor going to, all right, pin 8, 4 to 8, 6 and 7 connected, okay. And then between 6 and ground, that's gonna be nasty, 10 microfarad. Oh, these might have to be adjusted as well. I want to go ahead and try a 2.2 because the original circuit is meant for something like a 15-second impulse or something like that, or 6 seconds. Anyway, much longer than what I need, which is about 1 second. So this is going from pin 6. Pin 6 here. Should I just... Oh, but that looks horrible. Okay, I'm gonna do this. It's a little bit better. Oh, 6, which is also 7. Silly me. See, when you're connecting stuff, you need to look at what the other pin is connected to, not just look at the whole picture, not what the actual component is connecting to. So 6 will also be 7, which means I can just place it here. Kind of over the edge, but the other way around. Oh no, the minuses, it was okay. Minus to minus. Yeah, this turned out alright. Be sure not to touch other pins. It's disconnected. Sure appears so. And I'm afraid we have finished the circuit. Should be right. Okay, minus. We should have 1, 2, 3, 4, 5 components going to ground. First one is the IC. 2, 3, 4, 5. Is it 5? Capacitor 1, 2, 3, 4, 5. There's 1. There's 2. There's 3. There is, yep, 5. Always double check your circuit after you've done soldering, because sometimes you can just, connect the component to the VCC instead of ground, or switch sides or whatever, and you just look at it and wonder why it's not working, and you just soldered the pin next to the pin that should have been soldered, and so on. So it's worth checking these things. How am I gonna test this? I'm gonna need a resistor. 1K8 I think should be enough. Going to pin 3, which is the output of the 555. And I'll just have an LED. Like this one, and you can always check an LED with one of these 3 volts batteries. You can see it's perfectly fine. Give this guy a nice solder. Plus on the resistor. And minus on circuit ground. Now let's put in some power supply wires so we can feed some voltage into it. And now we should be ready to do some testing. Wow, this blade doesn't cut at all anymore. Oh man. It's no wonder, given that I've used it to shred plaster off a wall. Sometimes I really don't choose the right tools. Let me bring my power supply. This is a variable supply I've built myself. Now, professionals would consider this worse than any Chinese knockoff there is out there, but you know, it gives off a voltage that you can set from here, and that's basically enough for most of the stuff I do. You know, it has short circuit protection because I basically use the circuit at the output of a printer, 32 volt printer power supply, and that helped a lot. I mean, it's not just a transformer, and it's pretty neat for what I need. There you go, for 12 volts. Now we get to use the 555 tester I've built. I think that's how it was supposed to be. Right? Or is it the... I hope I'm not ruining it. I hope I'm not ruining it. Both on. I remember the plus was supposed to be the green side. Is this broken? ship is burning. What in the world? I think I just switched polarities. I think I might have burned one of the 555s. Really need to mark the polarity on this tester. Yeah, burnt that one. This one's okay. So I'm gonna place that here, being careful not to put it the other way around. And see what happens. This will be the minus. And here goes the plus. Okay, I'm waiting. Still waiting. LED came on. I needed to turn off too. It's no good if it stays on. I hope it does. There's go. Yeah, that timing though. Need to bring it down. It's way too much. Turn off the power supply. Which one will be this 470K?